Tired of confusing tech jargon? Welcome to the Why Explained. We cut through the noise to decode the systems and explain the foundational principle.
Imagine a simple instruction. If the light is off, turn it on. You don't need to weigh options or understand the room. You just execute the command. For decades, this strict if-then logic was the standard way we taught machines to operate. Take this vintage thermostat dial. In a closed, predictable environment, binary logic is flawless. The thermostat doesn't need to understand what temperature feels like. It only needs to know that when the dial hits exactly 70, it kicks on the heat. This predictability scales directly into mathematics. On a scientific calculator, when you press the square root button, the hardware executes a predefined sequence of steps to arrive at the same answer every single time. There is no room for interpretation. These rule-based systems offer total control and perfect clarity. If you know the rules written into the machine, you can predict exactly what it does. But that control only lasts as long as the environment behaves exactly as expected. Because this logic was so reliable, early researchers theorized that human intelligence was simply an immense collection of these fixed rules. They believed that building a thinking machine was just a matter of writing enough code. To test this, engineers built mainframes that took up entire rooms, filling them with vacuum tubes designed to process thousands of if-then statements simultaneously. At first, it worked. Machines like Birdie the Brain could beat humans at games. But games have clean boundaries, win conditions, and restricted parameters. Flawlessly executing a game of tic-tac-toe gave programmers a false sense of security. They mistook a masterfully coded closed loop for actual cognition, assuming that scaling up the code would eventually yield a machine that could think. The problem is that the physical world does not resemble a laboratory.
Now you know the why behind this concept. If you want to master the systems that run our world, hit subscribe for more foundational explanations.